Okay, so you get a little scratch, and you don't even think twice about it, right? It just heals. But if you ever like really thought about how crazy that is,
Yeah.
that our skin can just fix itself like that.
Right.
So tough, so flexible, and it just heals, no big deal.
Yeah, it really is remarkable.
And that actually is what today's deep dive is all about,
Yeah.
because scientists have made this new hydrogel, and get this, it's strong, it's flexible, and it can even heal itself, just like skin.
Oh, wow. So like mimicking the properties of skin.
Exactly. Pretty cool.
Oh,
Right. And to really dig into this, we've got some great research to go off of.
awesome. Yeah. Where's this coming from?
Well, we've got findings from the University of Beirut and Aalto University.
Okay.
It was all highlighted in Nature Materials and then like picked up by a bunch of science news sites, so it's getting some buzz.
Okay.
So what we're going to do today is break down how this hydrogel works, what makes it so special, and think about what it could mean for the future. Like, what could we use it for?
Right. Sounds good.
This is your like crash course into this super cool new material.
All right.
So, we see gels everywhere, right?
Oh, yeah. Absolutely. Like what? In like hair products?
Exactly, hair gel.
Yeah. Foods even, right?
Yeah,
Like gelatin.
totally. But
Okay.
for a long time, scientists have been trying to create gels that weren't just strong or just self-healing, but had both,
Right.
which is what our skin does.
Yeah. That's been the real challenge, right? To get all of that in one.
Right, like you could have a tough gel that if it ripped, that was a game over, or you could have one that could heal itself, but then it would be like super delicate.
Exactly.
So this new hydrogel is kind of a game changer. It can be strong and heal itself.
Wow. That is impressive.
Yeah, so how do they do it? Well, they found a way to use these special things called clay nanosheets.
Interesting. Okay. So clay at a nano level.
Yeah, and when we say nano, we're talking tiny, like thousands of times thinner than a human hair.
Oh, wow. Okay. That's so small.
Yeah, and these aren't just any clay nanosheets. They're synthetically designed.
Yeah.
And we can thank Professor Joseph Brew from the University of Beirut for figuring out how to make him.
Okay, so these super thin nanosheets are added into a typical hydrogel.
Yep, and you'd think adding clay would make it brittle, right?
Yeah, that's what I would think too.
But it's actually the opposite. It's what gives it the strength and flexibility and the self-healing.
Really? Okay, I'm curious how that works.
But when these nanosheets go into the gel, they kind of line themselves up, and the polymers, which are those long chains of molecules in the gel, they get all tangled up between those nanosheets.
Oh, I see. So it's like creating a really organized structure within the gel.
Exactly. And that structure, that's what gives it those great properties.
That's fascinating. So it's not just the material itself, but how it's structured.
Right. It's like Professor Bruce said, imagine a stack of printer paper, but each sheet is separated by just 1 millimeter.
Okay.
And then imagine the polymers are like squished and woven between those sheets.
Oh, I get it. Like all organized and layered.
Exactly. And, a 1 millimeter thick hydrogel can have like 10,000 layers of those nanosheets.
10,000.
Yeah, crazy, right?
Yeah, that's wild.
And that's what helps it be so strong and stretchy and, flexible like skin.
Okay, so we've got this picture of the structure now, but how does the actual self-healing happen?
Well, that's where the idea of polymer entanglement comes in.
Okay.
So imagine like a big box of yarn all jumbled up and tangled together.
Okay.
And that's kind of like how those polymers are, except, on a super tiny scale.
So like microscopic yarn?
Yeah, exactly. The researchers called them tiny wool yarns.
Yeah. I like that.
So they're just like constantly moving and twisting around each other.
Okay.
And when they get super tangled, they're basically all mixed up and you can't tell one from another.
Oh, interesting.
And that's important because it lets them move around more freely.
Okay.
So when the hydrogel gets cut, those tangled polymers, they break apart. But because they're so mobile and like clingy, they can find new polymers to entangle with on the other side of the cut and basically reweave themselves together.
Well, that's super cool. So they're like little repair crews?
Exactly. And get this, the research shows that within 4 hours, like just 4 hours, the hydrogel can heal itself like 80 to 90%.
4 hours? That's amazing.
You imagine a big rip in the material, and in just a few hours, it's almost completely fixed.
Wow.
And then usually within 24 hours, it's totally healed.
That is so fast.
I know, it's really amazing.
So it's really similar to how our skin heals.
Yeah, totally.
Yeah.
And I'm curious about how they actually make this hydrogel.
Yeah, is it like just clay and water or something?
Not quite. It's a little more complicated. They start with a powder of monomers, which are like the little building blocks that will link together to form those long polymer chains.
Okay.
And they mix that powder with water that already has the clay nanosheets in it.
So it's like a special mixture.
Yeah, and then here's the cool part. They bake it.
Bake it like in an oven.
Well, not exactly. They
Yeah.
use UV light, kind of like how they cure gel nail polish.
Oh, interesting.
So that UV light gives the monomers the energy to bond together, and then boom, you've got the hydrogel.
Okay, so light is the key ingredient.
Yeah, it's really neat. And, this whole thing is really inspired by nature.
Oh, for sure, mimicking the properties of skin and all that.
Yeah, it's a great example of biomimicry, where scientists look at things in nature and try to copy them to create new materials.
Right, borrowing ideas from nature's designs.
Exactly. And the potential applications for this hydrogel are just massive. Like, it could be huge.
Yeah, I bet it could be used for a ton of different things.
Yeah, like in medicine, think about drug delivery systems.
Oh, okay. Like a patch that releases medication.
Exactly. And if it got damaged, it could just heal itself so the medicine keeps flowing.
That's a great idea.
And then wound healing, too. That's a really obvious one, right?
Yeah, self-healing bandages.
Exactly. It could be amazing for burns or surgical cuts or even chronic wounds that are really hard to heal.
Oh, yeah. That makes a lot of sense.
And then beyond medicine, think about soft robotics.
Oh, right. Yeah.
Robots that need to be strong and also have like a sense of touch that could really benefit from this self-healing skin.
That's wild. Like robots with skin that can repair itself.
Yeah, it's almost like science fiction becoming reality.
It really is.
And then the researchers also talked about the possibility of creating synthetic tissues that can repair themselves.
Oh, wow. So like growing tissues in a lab that can heal on their own?
Yep, it could revolutionize regenerative medicine.
That's incredible.
And, all of this is really a big deal because for a long time, scientists have been struggling to create hydrogels that are stiff and strong and can also heal themselves.
Right. It's been a challenge to get all of those properties in one material.
And the researchers even said that this new way of strengthening hydrogels could completely change how we develop new materials that are inspired by biology.
Yeah, they're saying this discovery could like revolutionize the development of these bio-inspired materials and even like renew the rules of material design.
That's a pretty bold statement.
Yeah, it really emphasizes how significant this discovery is.
Right. And they said that even though real-world applications might be a few years away, this is a pivotal leap, a fundamental discovery.
It lays the groundwork for so much more.
Exactly. So basically, we've learned that scientists have made this amazing new hydrogel that's strong and flexible and can heal itself just like skin.
Right, and it's all thanks to those clay nanosheets and the way they make the polymers tangle up.
Yep, and that entanglement lets the material fix itself when it gets damaged.
It's pretty mind-blowing.
I know. It's a really great example of how we can take inspiration from nature and use science to create something incredible.
Absolutely.
So think about it. What if we could make stuff that could just fix itself like our skin does?
Yeah, that would change a lot of things.
How would that change medicine?
Robotics.
Even everyday objects?
It's really exciting to think about.
Yeah, and what other amazing things are hidden in nature just waiting for us to discover them?
Who knows what the future holds?
That's what makes science so cool.
I completely agree.
All right, well, that's our deep dive for today.
Yeah.
Thanks for joining us, and we'll see you next time.
See you then.